Hey students, what do you think? You do? We are doing chapter 4 and need to talk about 4 kinds of validity. And these are things we use to determine whether or not a research study has done a good job and we can accept the claims that they're making, whether it's a frequency, association, or causal claim. So what I'm going to do is briefly review, well, not review, but introduce these 4 validities, and then you need to read about them in much more detail in your textbook. So let me get up a couple of slides for us. Okay. All right, there are just 4 we need to go over. The first is construct validity, and this has to do with the variables used in the study. So if it's an association claim like a correlation, you have at least 2 things that you're measuring and you want to see if they're connected in some kind of relationship. And this could be, do kids, let's see, with higher GPAs have higher self-esteem? Okay, GPA is pretty easy to measure. We know how we would do that. How do you measure self-esteem? Is it by some kind of little survey they take, or you interview them, or there's a number of ways you can measure that. So construct validity, the construct would be self-esteem, or the thing you're trying to get at. And a lot of times in psychology, the things we want to measure aren't things you can really see. Sometimes they are, like a behavior, but sometimes they're things about us, personality, how we feel, our attitudes about things. And so we have to find a way to measure that. And if we did a sort of bad job of it, well, then our conclusions can't be trusted. Or if we had some bias in how we measured it because we have a certain outcome that we're hoping for the study, or something we already think is true, and we design the study to support what we think is true, we may introduce a bit of bias into how we measure it. So construct validity is, of these 4, something that applies to any study you see, whether it's a frequency claim, association claim, or a causal claim. You're always going to be asking questions about construct validity. How did they measure that? A big part of this is going to be the operational definition of the measure, and that's something we'll see in chapter 5, so we'll get to that. External validity, you probably have heard of. This is when you get the results of a study. Any study is only going to have 20, 40, 50 people in it, maybe even 1,000 people or 5,000 people who were surveyed. But the question then is, the data we got came from the sample, but we don't care necessarily about those 20 people or those 5,000 people. What we really care about is the population they represent. So we want to know, well, we got this data from 120 people. How well is it going to then generalize to people outside of the study? And is it only going to fit with people very similar to those who were in our study, or is it more generalizable? So a lot of psychology, of course, is done on, freshmen, psychology majors or college students. And we collect this data, we make some conclusions, and then we have to ask, but does it apply to people who didn't go to college, or people who are older, or people with different backgrounds? That's all wrapped up into external validity. So one of the big issues in how externally valid your conclusions will be, or your study is, well, how did they get the people in their study to be in there? How did they recruit them? Were they people that volunteered, or did they have some kind of random sampling and they went out into the community? So these, again, are questions you can ask about any kind of study. Frequency, association, causal claims, you can always ask about external validity. So these 2 apply to everything. Now, statistical validity, to some extent, does have to do with, did they do their stats right? Did they choose the correct test? Now, I'm not worried about you guys asking quite that question in this class, but what we might think of more is, okay, so they found a correlation, some kind of association. Well, we might then ask, how strong is that correlation? Is it just a little weak relationship, or is this something that's really tight, and as one variable moves, the other definitely moves with it? And it's very, we know, for example, the taller you are, the more you weigh. There's some correlation there. Obviously, there's tall, skinny people and short, heavy people, but there's a pretty reliable, connection there between those 2 things. Now, when we run experiments, we might ask for statistical validity. Well, yeah, it's statistically significant, but how big of an impact does it make? How big of an effect does that independent variable have on the dependent variable? So if you may have heard things like, oh, if you sit in the same seat for a class to take the test where you sat all semester, that should help your memory and you'll get, that'll help your grade. Well, the question in effect size or statistical validity, how big of an impact does that factor make? We could probably show, and I think they have, in large samples, that students who sit in the exact same seat might get a little bit better test grade. But we're not talking a big impact. We're not talking, well, if they sat in another seat, they'd get a C, but if they sat in the same seat, they'd get an A. That would be a huge impact, and that's not really what that kind of factor would show. It'd be like might be able to measure it, but it'd probably be very small. So that's what we're asking. When you draw a conclusion, and this is something that you're only asking about association claims and causal claims. Frequency claims are just a piece of information, a data point. 62% of people surveyed think this, right? So in statistical validity, it's really mostly the association claims. So how strong a correlation, or the causal claims, how big of an impact or effect size is there? Okay, last one, the internal validity. Now this is only going to be an issue with experiments, okay? Because internal validity refers to, well, how well was the study designed, but specifically, did your experiment rule out any alternative explanation? Was it well designed? And we know in correlations, we're just looking at two or more measured variables and seeing if mathematically there's a connection. But in experiments, we're trying to say X causes Y. And I can only claim that if a number of things are true, if I've ruled out any other possibilities. So I'm going to go low tech for a minute and use an example. I keep using a drug example just because it's quick and easy to wrap your head around. So here's my, I don't know if this is backwards for you. It looks backwards to me. Whatever. It's 3 groups, okay? And, okay, so let's say one group gets the placebo, one group gets the old drug, one group gets the new drug. And I'm trying to see if my new headache medication works better than the old medication. So I've split my people into 3 groups. The IV is, what drug you get. There's 3 levels, 3 groups. You get the placebo, the old drug, or the new drug. Now, I give everybody the drug, I wait a little while, and then I measure my DV, which is how quickly did your headache go away. So there's my experiment, and let's say the new drug, the people report the headache went away faster. So I'm saying, yeah, my new drug works. Now, to ask questions about internal validity, what I have to ask then is, how well did I do that study? And there's any number of ways I could have screwed this up. So I need to ask, well, how did I recruit my people and then split them into groups? I had to have random assignment. If I didn't have random assignment, I have no internal validity, because if I had, say, put people into groups without using a random procedure, what if people who had just a little bit of a headache got in the new drug group, and the people with the horrible headaches got into the old drug group? And so it wasn't the difference in the medication that made the headache go away faster. It was actually just how severe was your headache to begin with. And that would be something that, I'd have to throw out my data and my conclusions, because it wasn't the drug, the new drug, it was something else that gave me my results. How else I could have screwed up the study? Oh, what if, like, when I was mixing up the new drug to give it to you, I did a really good job and you got your dose, but the old drug, maybe it was really old and it wasn't working anymore, or when I mixed it up to give it to the people, I did a terrible job and it didn't dissolve and they didn't really get a good dose of the drug. So it wasn't actually a good comparison because I messed up when I prepared the drug to give to my sample. Anyway, you get the idea. Those are the sorts of things that can go wrong in a study, and that has to do with internal validity. Did you design your study and do things carefully in a way that made sure the results you see are actually the independent variable, what drug you got, affecting the dependent variable, how quickly did your headache go away, and it wasn't something else that was a problem in the study that was producing the results that I saw. Okay, So in chapter 3, there is a great table that kind of reviews the 4 types of validity, and then another table that shows which kinds of claims are each validity important for. And I just wanted to introduce the idea. So now if you go and do the reading as assigned in that chapter, there's good examples, there's more detail. Remember, the textbook is pretty much replacing lecture. Textbooks are written very well these days, so we can do that. And so you really need to look at that stuff and then, take your quiz and do the assignments as directed. All right, have a good reading.